college sheet of paper and let's kind of pull ourselves together and figure out what is given to you and what is not given to you as far as the integration formulas are concerned. So if I'm looking at it with you, it's on the back, okay? We went through differentiation just as a quick review. We have just the basic f of x, I say f prime of x. Then what's the next thing down for differentiation? X to the n, and then n x to the n minus 1. What do we call that?
The power rule?
Power rule, very good, excellent. And then do you guys recognize the ln of x is 1 over x? How do you do it? That's generic with x. How do we do it with a u?
Du over u?
Du over u. Does that sound, you might want to write that down for yourself. Or we also talked a little bit about e to the x. The derivative of it is e to the x, right? Sine is cosine. Cosine is negative sine. Tan is secant squared. I went a little bit further and I explained to you how to do secant, cosecant, and cotan as well. I showed you how to go through those. UV is like the product rule. They write it a little bit different than I do. The derivative of the first times the second plus the first times the derivative of the second. And then U divided by V is the quotient rule. Low D high minus high D low over low low. So don't look at the last one for the moment. We'll talk a little bit about that later. But if you see, we have gone through pretty much all the differentiation rules. Everybody cool with what I just said? Okay. So what we're going to do in the same breath is we're going to go through the different integration rules. And then we're going to talk about the last two parts of the integrations. That's the last lesson. Remember I told you something new? That would be the new, okay? So just kind of keep an eye. This particular page has a lot of good info for you. So it gives you a lot of the good stuff. So first and foremost, if I ask you to integrate something, there's a symbol that I use to show you how to take an integral. Squiggle. It's that squiggle, right? It's a universal, let's take an integral of something, okay? So there's multiple rules on figuring out how to take the integral. The first is probably the basic rule. Okay, if something is in the actual state of x to the n. Does anybody remember what the actual integration of it is?
Then x to the n times
the n plus 1.
You go up 1 instead of down 1.
And then divide by
That exponential power.
n.
That exponential power. And then one more.
and then
Plus
Add plus c
Plus c.
if you don't have an a and a b.
If you don't have an a and a b, okay? All right. If you have an a and a b, it is referred to as the fundamental theorem of calculus. Okay? It's the same kind of concept. If you have an a and a b, you approach it the same way you did here. So for example, its integral is that, okay? At that point, I would tell you that I've actually done the integral of it, complete, okay? So I say, done the integral, straight line up, remember that? And I say I'm going to evaluate it from A to B.
Then take an a, stick it in everywhere in a b, and stick it in everywhere and subtract the 2.
Vice versa. Take B
Or
and
yes,
stick it in first, take A and stick it in next, and then subtract the 2.
so you just stick it
Top and bottom. So yeah, it would be x to the b plus 1 over b plus 1, right?
Wait, what?
Oh, we stick it in the n?
No, you don't.
No, it's the n. Yeah.
You stick it in the x.
I was like,
So it would be easier if I did it as an f of x function. Okay. There. So. There it is. So when you integrate, it becomes the original function, and you evaluate it. Plug the b in first, and subtract the plugged in a. So remember, if there's an a and a b, you don't need a c. Yes?
Where do you get the A and B from?
Okay, those are given. Those are actual, like, if I know what range I'm going to work on, so we'll do a basic for now, okay? So let's say my function is x squared, right? Let's say I want to integrate that. So the way I tell you to integrate it is I'm going to take the integral of x squared. So how do I find the integral of x squared? I add that one whole, and I put it over itself, right? Are we good so far? Now, because I don't have a starting and an ending point, I don't have an A and a B. So I'm going to say plus C. Visually, I can show you why that works. So let's say I also have, let's say my new f of x is x squared plus, there we go. Okay, so typically if I'm doing this, I get x to the third over 3 plus 3x. If I'm talking about going the other way with it, so let's start with my original function. Let's say I have x squared, I have x squared plus 3, I have x squared minus 4. First I want you to take the derivative of each of them for me. Okay? So what would the derivative of x squared be?
2x.
What's the derivative of x squared plus 3?
2x.
What's the derivative of x squared minus 4?
2x.
So what do I see?
They're all 2x.
They're all 2x.
Constant goes away.
Right. So now if I integrate it to go back to its original, okay, I get 2x squared over 2. Would you agree?
Mm-hmm.
Okay, so I'd get 2x squared over 2, which is x squared. Yay me, I did it right. Right? But what would this one be?
2x.
Also x squared. No, I didn't do it right. You see? So that's why the plus C indicates something could have been added or subtracted to the end of it.
Okay.
Does that make sense?
This is kind of like a placeholder.
Kind of, sort of, because I know that the derivative of each of them is 2x. I know that to take a derivative of it and then to go backwards, it could give me any of those, but I'm not sure which one. Okay, so far so good? Now, back to the A and the B. So I had x squared, and I took its integral. Okay, now I'll get rid of this because that made better sense. Let's say I want to do the same problem. I want to find the integral of x squared, but I want you to tell me the actual value from, let's say, 3 to 5. What does that really mean? Yeah.
3 to 5 when it's, what's it called?
It's a good question.
Underneath.
Right, underneath.
Integral line, underneath the line.
Underneath the line. Perfect.
Okay.
Yes.
The 5 and the 3 are 2x values.
2x values.
When it's 0.
So we have 1, 2, 3, 4, 5, right?
Yeah.
And what does x squared typically look like? Well, it's a
Parabola.
right? And I want to know from 3 to 5, underneath, what am I actually finding from 3 to 5?
The area under the curve.
The area from 3 to 5. Does that ring a bell?
Mm-hmm.
Okay. When I don't have an A and a B or a 3 and a 5, it's just saying, in general, it could be any of these values. Okay? Because you're not sure where you're looking at. Specifically, I want to know from 3 to 5. So how do I do that? So I'm going to go x cubed over 3. Everybody cool with that integral? And then I'm going to tell you I'm doing it from 3 to 5. And here I didn't have any values. Because x squared could have been any of those spots, and I could have found the area anywhere underneath it. And then what do I do?
Plug in the 5.
Plug in
Subtract
the 5.
the plugged in 3.
Minus plug in 3. Okay. I get what? 125 over 3 minus 3 times 3 times 3 is 27 over 3. And I get 98, 70, yeah. There you are. Are we good?
Mm-hmm.
Does that kind of ring a bell from last year? A little bit?
Mm-hmm.
Starts to sound a bit familiar? Okay, so that's just the beginning. So how do we handle, that was just the first on your little list of things. That was your x to the n over that. How do we handle something that looks like this? I'll give you some examples. And I'm going to put a dx to the side of it. What's that mean? That means the derivative had been taken. Now I can take an integral of it. That's all that means.
Which one is this?
This is just an example I have that you don't have. So how do I handle this? 2x minus 3. What do I do? I'm going to take an integral of it, and how do I know that? Who's that? Squiggly? No U's.
The parentheses is gonna be, everything that's inside of it is gonna be x. So you don't derive what's inside, you just.
Chain rule.
No, it's not chain rule. There's nothing being applied to it.
What's the power of it right now?
1.
So truly, can't I just say this?
Yeah.
Right?
The only time we worry about it is if there's a power.
And truly, can't I say this? Does it mean the same thing?
Yes.
Mm-hmm.
What did I do? I took that 2x minus 3, because it's not squared. It's not square root. I just took it and kind of said, oh, I'm going to take individual integrals of both pieces. Yeah? Okay. So what's the integral of 2x? And how do I do it?
2.
2x squared over 2. Yeah? So far so good?
Yeah.
And then, so I'll clean that up in a minute. And then what's the integral of 3?
3x.
Yeah, right. Did I have an A and a B?
No.
So plus C. Clean it up. X squared minus 3x plus C, you have your answer. Does that ring a bell?
Yeah.
Mm-hmm.
The smiley face is not the official part of the answer, but
They might give you, they might.
Keep your bonus point. I like
they
your
might
style,
if
yeah.
you're, yeah, I
I
do
like
too.
your style. I'm happy you're happy.
Yeah, I don't think so. I don't think they like you that much. They're not going to say good job with the smiley face.
So you order them and see if there's an A and a B.
You always see if there's an A and a B. Now what?
It's squared.
So what do I do now?
Right.
No.
Well, you take it, the integral as if it's like, as if 2x plus 1 is an x, and then so do that to 3 over 3
You change
plus c.
a reverse chain rule. U-Substitution.
Okay. So there's two ways to attack this one. The first way is to recognize that 2x plus 1 squared is an easy fix. It could be, what? 4x squared plus 4x plus 1. What did I do?
You just factor or FOIL
Foiled
it
it
out.
up, right? And then I could integrate, plus c, life is good, move on.
Mm-hmm.
So let's do that just to see it. So 4x to the third over 3 plus 4x to the second over 2 plus x plus c. Clean it up if you see fit, and you're done. That is because it's a simple square. Now, had the original been 2x plus 1 to the 20th, you probably would say not so simple, right?
Do it.
But you know, some of you love math so much you could do it.
Fill up an entire page, just
Sit there for
solving
20
more problems.
minutes, multiplying it out.
You would remember the binomial expansion and get really excited that you could do it without having to really think about it. But okay, no,
right.
maybe not.
Yeah,
Right. Or you could use this thing called U-Substitution.
Let's do this thing.
Let's remind ourselves how it all works. Okay, I'm going to do it the old-fashioned way, and if you can remember how our friend last year did it.
It was
Yeah, so let's talk
Thank you,
first.
Ty.
Right. Let's go the old-fashioned way. Let's do it
Oh,
my
yes.
old way, and then we'll go back and review how he did it, and we'll all love him even more. Okay? So the first thing you do is you recognize that something is inside something else. Okay? So the situation I look at right now is I have 2x plus 1, and that is inside of squared. Do you agree?
Yeah.
It's like the outside case is the squared, and then the inside stuff is the 2x plus 1. So the stuff that's on the inside is what you're going to call U.
Me?
U.
Me?
That's right. Like that.
You.
You are 2x plus 1.
Aw.
I know.
I am.
I am 2x plus 1.
You are. That's you now. So the next thing I need you to do is I need you to take and find du. What does du mean?
The derivative of
of
u.
that u that you just named. Okay. So du is 2, actually 2 dx, because it means du over dx equals 2.
Mm.
Okay.
Okay.
This is what we refer to, by the way, is called a differential, because it could be written as du over dx is 2, and we just bring the 2 over. It's kind of a shortcut to the differential. All right, just FYI.
Just to tell you that you're respecting x.
That's all it is. A lot of people get confused. Why the dx over there? Well, because it's originally d over dx equals something, and then they bring that over. Okay, so far as that makes sense to all? So right now I have a u and a du situation. Ultimately, my goal is to rewrite this original problem in terms of u only. So if I'm looking at this, I have 2x plus 1, I have 2x plus 1, 2x plus 1 is u, or Ryan. So 2x plus 1, we're going to put u here. So it's going to be u squared. Okay. Now, what is du? All right, because remember, I'm trying to rewrite this in terms of du.
2dx.
So I'm looking at it, right? I got a problem, right? I got 2dx. I got dx. So I can change it, and I can put a 2 here. Now I have du. What's the dilemma?
You change something.
I changed something. So I have to do its alter in order for me not to have really changed it.
You gotta
Pull out its reciprocal up front.
Right, so what's the reciprocal of 2?
1/2.
1/2. There
I
it
really
is.
don't like this.
And that's du.
you're going to disregard all of this.
I know. When we do it
No
like
offense.
See, I'm
to you.
really happy
No
I
offense,
missed this
but-
lesson and then came back the day after and Ty explained the other way.
You're so good at it, right. Okay, so now what we're going to do is we carry the 1/2 of the ride, and we integrate like the old-fashioned way. So we have u squared, and what's its integral? It's u to the third over 3.
Mm-hmm.
So u to the third over 3. Okay. And instead of u, I really actually need to have it in terms of
2x
the
plus
x's.
1.
Right. So this would be 2x plus 1 to the third over 6, and then don't forget there's no a and b. So plus c. On a personal level, that's how I always did it. It's how I've been doing the U-Substitution for, the 2 years I've been teaching. But how in the world did he teach us how to do it? So let's review that.
See if I
My
remember.
mother God said you way.
It was so much nicer.
It was a serious godsend because I missed this last one.
Yes.
You take its integral as if 2x plus 1 was just an x, and then the denominator multiplied by the
Okay.
The derivative of the
so
inside, yeah.
Pretend this is just junk, right?
That's not good.
And then we keep it as it is. We take its integral,
Mhm.
right? Then what do we do?
times the derivative of the inside in the denominator.
Times the derivative of the inside in the denominator.
It's beautiful.
And you end up with 2x plus 1 to the third over 6 plus c.
Well, it was a lot quicker.
So I must admit that is much nicer.
Sorry, well, I missed, how do you get that?
You
bottom?
blinked your eye, right? I know, I get it. Okay, so the way I know is he came up with like, why don't you do it this way? I'm like, oh, we should. So for a moment, just take the derivative of something squared. What would that be? It would be to the third over 3. So whatever that something is, you keep to the third over 3. Okay? Then you take the derivative of that inside. Well, what's the derivative of the inside here?
2.
2. You attach it to the bottom. And you clean it up.
Can't wait to get one where it's like a chain within a chain within a
I know, because that makes it so nice.
Quotient.
And I'm just gonna stop.
So let's do it. He won't, no dying. No.
Get that board off that geometry.
That was so nice of him, as shy as he was to get up and do that and show us how to do it, right?
How well did he do on that test?
Yeah. Anyway,
But
there we go.
it's probably better.
All right, try that one without me.
4 points, come on.
We can do it.
If you choose to